So here is the non-entangled example of the principle of conservation of momentum. Two sleds of mass 0.4 kilograms and 0.5 kilograms are placed opposite each other on a smooth air track. At the point of collision, the lighter mass is travelling at 2u meters per second and the heavier mass at u meters per second. After colliding, the speeds are 3 and 1 meters per second respectively. Find the value of u. Now, vector quantities are very important here, so make sure you define your directions, and then either one of these has to be negative, and then be careful because it says speeds after collision. So with that knowledge, I want you to go ahead and try this problem, and when you're ready, come back for the solution. So here's the solution. I've defined going to the right as positive. So the initial velocity of the first is plus 2u, and the initial velocity of the other one is minus u because it's going opposite to the 0.4 kilogram mass. And then of course their speeds are 3 and 1 respectively. So we have our formula. So 0.4 times 2u plus 0.5 times minus u, because it's going the opposite direction, is 0.4 times 3 plus 0.5 times 1. Simplifying down, we get 0.8u in here and minus 0.5u, so we get 0.3u is equal to 1.7, so 1.2 plus 1.5. And then dividing through it, we get the initial speed, or the value of u, as 5.7 meters per second, which is the value of u. Now, 1.7 divided by 0.3 is just 17/3. So this one is traveling at 5.7, or the magnitude of it. The magnitude of the other is 11.3 meters per second. So the lighter one's at 11.3, the heavier one is at 5.7, and then of course they travel off at 3 and 1 meters per second respectively.